Righty-ho, time to finish this job up. Now that we've supported our brass, we have our mandrel in place. I need to install my radius turning attachment. So I made this project a few years ago now on a previous lathe. Yeah, I need to make sure that's clean actually before we get too carried away with installing it. Don't particularly want to go clamping down objects onto parts of the machine with chips of metal lying around. It can embed the chip into the lathe and damage it, and that would be not ideal. Likewise, this needs to be relatively clean. Then that can go in there. I only really need to do one of those up. So, radius turning attachment. This tool's not my favourite tool in the world to work with. This it does turn effective radiuses, but it's very hard to calibrate in order to get a decently accurate sphere. It works by the tool bit being able to be freely moved around the Z-axis, the vertical axis, and you can adjust the diameter of the sphere or radius that you're turning by loosening this Allen key and allowing the slideway to move backwards and forwards. At the moment this is set for a pretty small shape, to be honest, so I'm going to have a bit of a crack at setting the tool up rather, so that we're turning a reasonable radius. I'm going to do that off camera. It's going to take some fiddling and dicking about, and you test basically visually by going from the end of the sphere, which is the end of the part that we want, around until you're clearing the back of our blank. And that's the process. It'll take a bit of adjustment and trial and error until I'm happy with how it goes. But before we start cutting, I shall come back and we'll start turning this thing into a ball. So I've had a go at setting the radius that this tool is going to operate on. I'm probably just going to turn it by hand. I have used pliers in the past to support it. There's a risk that the pliers get too close to the chuck, which has corroded badly overnight thanks to the rain. Lovely. The pliers do get close to the chuck jaws, which is not very safe, particularly given your hands might be on it. And it tends to make for a very large swing out this way as well. Given we're cutting brass, probably get away without it, but we'll just see how we go. This tool was intended to have a handle come out through this face here. But the reality is I've lost a lot of interest in finishing this project. It works fine now, and it's not something I use a great deal. In fact, if I was to redo it again, I'd probably not go with a cross slide mounted radius attachment. I would make one that fits into the tailstock so that the rotational axis of the tool is always on center. It means the tool's only good for turning spheres or radiuses around that central axis, but that's all I've ever done with this attachment. I could, in theory, cut like a radius off the center axis with this tool. Something like a ball bearing seat is possible. I just don't do it. I haven't had a lot of justification for having that tool. So we're at a pretty high speed here, which is fine. We're cutting brass, even though it's high speed steel, it will manage with that just fine. This tool's still pretty sharp. Tends not to blunt very quickly. Don't do heaps and heaps of work with it. I'm out of gear. We're ready to go. So we just swing backwards and forwards. We are a long way out from the chuck. Not a great deal we can do about it. If we take smaller cuts later on, it'll remove any chatter marks. may necessitate me changing the rotational axis of this tool. I don't think I'm close enough this way because I'm not cutting this face. It is very close, but I think I might need to move my carriage that way just a whisker. Eyeballing the diameter at this point, I think I'm alright. See how that comes up. Pretty close. I'm just plunging in with the crossfeed axis. This is how you achieve depth of cut. Going relatively quickly at this point. I'm not especially interested in surface finish quality. I just want to rough this shape out, make some adjustments to my tool. Still think I've got the right radius. Again, I think I may have to go a whisker further in. There's a little flat part in the center of this part. I think I'll be pretty close to that, but I'm just going to play it by ear at this point. Move inwards just a little bit. Getting absolutely covered in brass shavings here. Going pretty good. Just about gotten rid of the flat on the outside. Might move you so you can get a better position and see what's going on. So I have resharpened and reinserted my tool. I've inserted it so that it is just contacting the face we were already working on, and I haven't moved anything else. So it should be where it was. I have made the geometry of the tool slightly different. I've gotten the nose of the tool and I've gone slightly downhill, called negative rake. I've done that, pardon me, because brass tends to like that sort of cutting pressure being exerted on it. I have also honed the tool and given it a slight nose radius. That is the front of the, front of the tool is slightly rounded, so that way it generally helps with surface finish as well. And it makes for a nice smooth product that we're going to be sanding after this. So I'm not super stressed about surface finish, but it is nice to have a good head start on it. It might make the tool chatter. If I do run into problems with chatter, I might regrind the tool again and delete some of that nose radius, but it's quite a small radius, so we'll probably get away with it. Anyway, let's continue. Seems to have helped with chatter. See if I've got my centre height a bit better. Yeah. A bit better, still a little high. So the camera is a little in the way for fixing that. I might adjust my surface finish. I might adjust the tool height and I'll come back. We're back. We've adjusted centre height. I've relocated the tool. Had a bit of a problem with it not clearing the job correctly. It had slipped back a bit in its holder. I've just taken one real light test cut for a resumed filming and it's looking good. So let's keep digging until we have a properly spherical object, but we're getting pretty close, as you can see. Not particularly steady coming from left to right. So it suggests to me that the angle on top of the tool that I reground might be just leaning probably to the left. And as I move from left to right, it's trying to screw its way into the job. It's one of the reasons why brass really likes negative rake tooling, is because if you have positive rake tooling, where the tool is wedged into the job, it tends to want to screw into it. Now I'm really close here. I'm just trying to get the last cut happy. I'm pretty satisfied with the shape. Surface finish on that pass looks pretty nice. That's starting to look pretty good. A little rough out on the end, it's hard to see on the camera, but yeah, I'm pretty satisfied to that. We've got something we can start polishing from. So I'm going to give this machine a clean down. I'm going to remove my radius turning attachment and refit my compound, and then we'll start polishing the ball. It is a breezy day and quite cool. So, last step, we're going to do some polishing on this sphere before we part it off, and once it's parted off, we're done. We're on the home stretch. Got a stack of water resistant, what is it called? Wet and dry abrasive paper. It's silicon carbide, I believe, is the abrasive material. And it's wet and dry because the glue they use to stick it to the paper, the backing, is waterproof glue, and the paper is somewhat water resistant as well. We're not terribly stressed about it being wet and dry paper. You can use other materials, but this generally tends to work pretty good with most metals on lathes when doing polishing, and it's readily available, so it's a nice way to go. I've got a range of grits. I'm starting at 360 and I'm going to skip every second step. I've got 600 after that, then 1200 I'm pretty sure, and 2000. 2000 grit is quite fine. It's actually getting a bit hard to find in Griffith, which is a bit of a pain, but I have a stash of it here, and it's quite nice for doing brass in particular. It'll be a mirror finish by the time we're done. You could fill in the gaps between those grits. There's between 360 and 600 is 400, and I have a feeling I might have seen 480 once upon a time. There's a range of different grits. With brass being quite soft, it's very easy to skip through steps a bit more quickly than you might do with hardened metals like a harder steel, like 4140 or something like that. But with brass, this should be fine. Now, I've also covered the bed and carriage of my lathe with a piece of paper. This is just some lint-free paper that cost a fortune, but it's useful for doing this sort of stuff. Big long roll of it, tear it off as required. I've done that because I don't particularly want lots of abrasive dust going all over the bed of my lathe. My previous lathe, I didn't really care so much. It was a pretty clapped out Hercus 260. It was also a lower spec model, whereas this one's one of the higher ones, and it's in really fantastic shape. So I'm going to go to lengths to keep it that way. One thing to note when sanding, I tend to go underneath the job and don't wrap material around. If you wrap material around, yes, you'll be able to sand things a lot quicker. You have more surface area of the sandpaper on the job, but as the lathe comes around, it's going to try and grab the sandpaper, and there's a chance that it could wrap around underneath itself and then self-tighten, and with your fingers on it, you'll go in there with it. We don't want to do that. I'm also going to fold my sandpaper in half. Two reasons. One, gives me a nice square straight edge to sand up the faces with, and not necessarily a problem in this case. But two, gives it a bit more heat resistance, so I'm not going to burn my fingers quite so badly as I'm doing this job. Other than that, I've checked that my chuck is clearing the piece of metal I've got lying around. Maybe I can wiggle that around a bit better. Nah, it's alright. It's sitting there. I'm still at a very high speed, and I'll stick with that until I finish the polishing process. So, let's begin. When you're polishing, you're going to find on a sphere that will require a lot more work on the end of the sphere than it will on the circumference, because the surface speed at the circumference is quite high. Every time it does a lap, it's got to travel all that way around, probably close to 3 inches or so. Whereas the very center of the workpiece is traveling at nearly 0 inches per minute. It's not traveling very fast at all, and so it's going to require a lot of work. The very center dot of it, in fact, will be traveling at no speed. It'll just be rotating on the spot. So to get the very tip of it, I'm going to go backwards and forwards a fair bit with my sandpaper. Just moving around. And that will get the center point knocked off. Work my way around to the rest of it. Now I'm looking to see if I'm actually making further difference to this as I sand. At some point I'm going to stop getting a reward for using the 320, and I'm just going to be removing material more and more. I don't really want to change the shape of my ball too much, it's pretty good. So once I've achieved about as good a surface finish as I'm going to get with the 320, then I'm going to move on to my 600. Now I've just noticed that there's a bit of a divot. Now that I've cleaned it up, I can see there's a bit of a divot right on the center point of this. That's a bit annoying. It's a little deep, in fact, so what I might do, I might get a file and just knock that down a little bit so that I can re-sand it from there. Just acquire a file. I have here a relatively unique file, not the sort of thing you will see in schools very often. This is a lathe file. It's a fine-toothed one. The angle of the teeth is quite steep, so when you are doing work perpendicular to the axis of the machine, it tends to leave a much nicer surface finish. So if you've got a part that you're turning down to diameter and you want to just remove the tiniest amount of material, maybe you miscalculated a cut or something like that, then this is a good way to very carefully sneak up on the surface diameter that you're after. For the example. So that's left a pretty nice surface finish, to be honest. It's when I come in for a closer shot and part it off, you'll be able to see it, but it's quite nice, to be honest. It's nearly as good as say 360 to 400 grit wet and dry paper. Like any file though, it will need cleaning regularly. You need to use a file card in order to remove the pins from the teeth of the file. This is a single cut file, which is another feature that adds surface quality but comes at the cost of material removal. I don't need to remove tons of material with this. I'm just going to use it to tickle the end of the ball here so that I can get that little nubby part away and go back to sanding. Not stopping in any one spot. Stopping in one spot will dig a hole in that spot, and it'll also clog up the file very badly. I removed some of it. May need to clean this file in a sec. Very close. Yeah, that's got it. So with that done, I go back to the start. I go back to my 360 grit and I'll sand the end of it. We'll have a closer look to see what we'll achieve. Yeah, much nicer, much nicer. Much better. Yeah, and get the rest of it looking nice. Move on to the higher grits. Probably as good as I'm going to get with 600. Move on up. Starting to get pretty shiny now. I don't think I could pluck my nose hairs in the reflection just yet, but I can certainly make out that somebody's in the reflection of the ball. Bit of a look. Very nice. Right, yeah. Now we're up to real polishing territory. 2000 grit. Just fold that into thirds. So, I'll bring you in, we can have a closer look. Nearly a mirror finish. Still a bit streaky. That's okay, we have a solution for that. Last step I'm going to go with will be some Brasso. Brasso is a bit questionable for its use in schools, I believe. I haven't done a lot of homework to double check this, but generally speaking, it's not something you want lying around for ready access to kids. It contains some hydrocarbons and ammonia, which is probably the more dangerous part of it. It's got a fine abrasive powder, I'm not sure what the abrasive is, suspended in those liquids. The liquids help remove tarnish, so it's converting oxidized brass back to probably either brass, or it's just allowing it to be abraded away, and the abrasives do some actual polishing. Going to do this as my final step. I'm using paper rather than fabric. Generally try to avoid using fabric on a lathe while it's moving, because fabric, if it wraps around the spindle, will be pretty dangerous, can drag you into the machine, and that would be not good. Got a bit on my bit of paper. We'll spin her up, give her one last polish with this. Well, I'll tell you what, that's looking pretty spectacular now. Little tiny bit of streakiness in it, not much. The tip is a bit harder to get, but I've got it pretty good. I've got a little bit of a flat spot there from where I've done that filing. I could go back to 320 grit and try and blend that radius back out of it. I don't think I'm going to bother. This is going on a machine tool. Probably go a little bit more over this side. I might even go back to my 1200 or 2000 grit rather, and give it a little bit more of a polish on the end. And once I've got that done, I might bring you back for parting off. Okay, I've just finished polishing my knob. Wait, scratch that. Just finished working on my knob. That's not heaps better. Look, I've done the job I was setting out to do. Let's go with that one. Last thing we need to complete is to retrieve my knob. God, it's getting awkward. I need to retrieve my knobs from our mandrel. I'm going to do that with a parting tool. This is an irreversible process, an irreversible step. Once I'm done with this, that knob is coming off the mandrel. It is not mountable again unless I make up a mandrel that uses a 3/8/16 3/8/16 mandrel, which I'm not really set up to do on this lathe. If I'm super duper desperate to polish my knob again in the future, and hey, sometimes these things happen, then I may make up a mandrel, but at this point it should be fine. So I'm going to bring my parting tool in. I'm just lightly going to face off the back of the knob, just. It's not too bad looking. I just don't want to step back there where I've had the shoulder go up to the thing. Now, before I start hacking this thing off, I'm going to need something to catch it with. Probably a good bet will be the piece of paper that I was polishing it with. It would probably work pretty good. So I'm going to hold it with that so that when the parting operation finally releases my knob, I'm not going to drop my beautifully polished knob down into the chip tray of the machine and scratch the crap out of it. I've left my cutting speed high. I know that insert's still pretty good. We swapped it over in an earlier video. So that should be it, ready to go. Going to go nice and steady, just so I get a nice surface finish. Just trying to keep it neat and presentable. And there we go, I've got my knob back. Our mandrel has done its job. Now I've got a bit of a nasty burr on the back here. Might attempt to remove that with a countersinking bit, holding the job by hand. I don't want to scratch it up too much, so we'll keep it separate. Oh, she's quite warm. So I'll get set up with a countersinking bit and we'll attempt to deburr the back of the knob. So around on the workbench, I've got my drill. Just going to do this one by hand. I'm a big fan of 240 volt drills because I'm not a big fan of buying batteries on the regular. Everything I do in my shed is near a power point anyway, so having a battery tool tends to be a bit more of a liability than anything else. Gently. Yeah, it's cutting it down. Now I'd love to be able to hold this and do it some other means, but unfortunately I can't hold it in a chuck anymore, can't hold it anywhere else. We're kind of committed. That's okay. very close. A few stuck bits here. Just don't want to come. Maybe we can cut them off. This tool I'm using, very high tech bit of kit, is actually an old power hacksaw blade. If you do manage to come across some in your travels, they make really nice workshop knives. You just sharpen an end at 45 degrees. Yeah, it's not bad. I'm satisfied with that. Do one nice little tickle with this. Proper hole deburring tool would be really nice. Maybe I'll try my regular one. Oh yeah, that actually goes alright. That's the ticket. Yep. Okay. Full of schmutz at the moment. I might get a tap. In fact, I might be super lazy. And gently, gently throw it on my hand to be smart. There we go. Good. Give it a blowout with a compressor and we're installing. Nothing like taking an old crusty knob off. Oh, we do need to clean that actually, don't we? Better get a wire brush. Give her a bit of a scrub. Yep. Wouldn't it be funny if it didn't work? Oop. Look at that. Beautiful. Now I've got a shiny brass knob to play with. Fantastic. Thanks for joining me on this project, guys. If you have any ideas for other projects you'd like me to have a look at, maybe something you've seen me working on at school, one of the school projects we have coming up in the future. I believe the next one I'm going to be looking to film is a Year 7 job, but I'm going to be doing a redesign of the dustpan template. I don't quite like the one we've got. Some of the shapes on it don't line up quite as nicely as I think they should. So that'll be my next filming project. But if you have any other ideas or requests, feel free to hit me up in the Google Classroom or in the comments on YouTube. Until then, we'll see you next time.